Now see here, first of all I welcome all the students and the participants who are attending this live lecture. Today in this lecture we shall discuss the relative compactness, definition regarding relative compactness, epsilon net and totally bounded sets. Now see here in this lecture we shall study, okay, see this. Up till we have studied finite intersection property, relative compactness, epsilon net and a totally bounded set. Now see here, this is the definition. We shall discuss the definition. A subset capital A of a metric space XD is said to be relatively compact if A bar is compact. If A bar is compact. A subset capital A of a metric space XD is said to be relatively compact if A bar is compact. Now see this, the concept regarding relatively compact. We shall discuss this. Suppose this is a metric space XD. This is a metric space X comma D, and A is a subset of metric space XD. Then the relative concept regarding the relative compact is, if A is compact, whenever A bar is compact, A bar means the closure of A. What is mean by closure of A? The closure of A means which includes its limit points. अगर A set में उसके limits point होते हैं, suppose this is a A bar which includes the limit point C is, and this is suppose A. Okay, ये तो relative की compact है. Relative यानी कि इसका मतलब क्या होता है? अगर A bar compact है तो उसका relatively compact का मतलब वही होता है कि 1 minute. ओके, तो वो रिलेटिवली कॉम्पैक्ट का मतलब होता है अगर ये बार कॉम्पैक्ट है तो ये भी कॉम्पैक्ट होता है. इसका रिलेशन है, रिलेशन ए बार इज इक्वल्स टू ए बार इफ ए इज क्लोज्ड सेट. इसको काय को ये इज क्लोज्ड सेट. रिलेटिवली कॉम्पैक्ट की डेफिनेशन विच इज यू नो दैट क्लोज्ड सेट इज अ कॉम्पैक्ट सेट. अगर ये क्लोज्ड होता है, note that, see this, A is closed, then A bar is equals to A और A equals to A bar. फिर अगर A bar compact है तो A is also compact, so we can say that it is a relatively compact. Second, what is that? We have seen that the compact set is always closed. We know that the compact set is closed. आपको पता है compact set closed होता है. अगर set closed होता है तो A bar is equals to A होता है. That implies A bar is equals to A. So A is called relatively compact. A is called a relatively compact. Okay. Now we shall discuss the second definition regarding the epsilon net. Okay. Now we shall discuss the second definition, that is a epsilon net. Second definition, epsilon net. what is the mean by epsilon net? We shall discuss this. A finite set capital F, see this, a finite set of a capital F of metric space x comma d, and epsilon is greater than 0 is called epsilon net, if each small x belongs to capital X, there exists a point P, small p, belongs to F such that distance of small f comma p or px comma p which is less than epsilon. See this. This is one definition of finite set capital F of a metric space XD, or we can say that a finite set capital E of a metric space XD and epsilon is greater than 0 is called epsilon net if each small x belongs to capital X, there exists a point P belongs to F such that distance of P comma F is less than 0. Epsilon. This is one definition. Or we can also define another definition. Suppose this XD be a metric space, and suppose F is the subset of a metric space X, then there exists a point P and X whose distance is लेस देन इप्सिलॉन. ये जो डिस्टेंस होता है ये स्मॉलेस्ट होना चाहिए. x अगर कौन सा भी सेट है, x इज अ मेट्रिक स्पेस है और f इज अ सबसेट ऑफ x होता है, तो इप्सिलॉन नेट का मतलब क्या होता है? देयर फॉर ईच इप्सिलॉन फॉर अ पॉइंट, और वी कैन से दैट फॉर ईच स्मॉल x belongs to capital X such that distance of x comma f is belongs to this. Or we can write another definition, or we can write second definition of the epsilon net. See this, a finite set capital F of a point capital F of points, 1 minute, F of points of capital X is called epsilon net for k or for x, epsilon net for x, if for every point x belongs to capital X, there exists small y belongs to capital F such that distance of x comma y which is less than epsilon. अगर आप इप्सिलॉन नेट का मतलब क्या होता है, ये सिंपल कंसेप्ट है. अगर x is a non-empty set and f is a subset of x, or we can say that metric space X, then for every point of x there exists a point of y there exists a point of f, that is y belongs to f, such that distance of x comma y which is less than epsilon. Suppose this is x, this is a y, then every point of x we can say that distance of y, x comma y which is less than delta, which is less than epsilon. ये देखो, ये यहाँ पे x is a point of x होता है, क्योंकि आप बाहर भी ले सकते हो, यहाँ पे ले लो. Suppose this is x1, this is y1, then less than epsilon. Okay, we shall see one example, one by one example, then we get the clear concept regarding this. For example, let capital F is equals to set of, suppose 1 minus 1 comma 1, 1 comma 0, 1 comma 1, 0 comma minus 1, 1 comma minus 0, minus 1 comma minus 1 is, say this, is and 3 by 2 net for x equals to set of x comma y belongs to R square such that x square plus y square is less than 4. Suppose this is a point. Suppose this. If we consider a point, this point is 1 comma 0, 1 comma 0, this point is minus 1 comma 0, this point is 0 comma minus 1, this point is 0 comma 1, this point is suppose 1 comma 1. ये डिस्टेंस अगर लेते हैं तो वो √2 होता है, सी दिस 1 1. सो जो पॉइंट का सेट होता है ये, इसकी वैल्यू 1/2. मैक्सिमम डिस्टेंस कितना है, देखो ये मैक्सिमम डिस्टेंस यहाँ पे ओपी है, मैक्सिमम डिस्टेंस यहाँ पे कितना है, ओपी है. अगर हम ये x is equals to x square plus y square which is less than 4, or we can say that r square less than r square, r is the radius of that, you know that radius of this sphere. तो यहाँ पे हर जो पॉइंट होता है, यहाँ पे जो हर एक पॉइंट होता है रेडियस लेस देन 4 ले लो, लेस देन 2 ले लो. ओके, लेस देन 2 लेता हूं मैं यहां पे, 1 मिनट. सपोज दिस इज 2, रेडियस इज 2. तो हर एक पॉइंट जो होता है ये एफ वाला, और ये जो एक सेट है, हर एक सेट होता है, तो इसमें किसी भी पॉइंट की वैल्यू इप्सिलॉन नेट, इप्सिलॉन नेट मीन्स इप्सिलॉन की वैल्यू कितनी होती है, 3/2. So we can say that distance between these 2 points are suppose less than or equals to 3/2. 3/2 यानी कि 1/2. Here distance of x comma y which is less than epsilon, where epsilon is equals to 3/2. कहां पर भी डिस्टेंस मेजर करो, उसकी वैल्यू मैक्सिमम डिस्टेंस देखो यहाँ पे √2 होता है, √2 की वैल्यू 1.5 41 यानी कि 1.5 से कम होते हैं, 1.5 यानी कि 3/2, which is also known as a 1.5 suppose. So this set is called as the epsilon net for f is the epsilon net for x is equals capital X, which satisfies this condition. Okay, now we shall discuss the second definition, second example. What is that second example? Let capital X is equals to 0, 1 with the usual metric, what is the condition with the usual metric? Space and epsilon greater than 0 of finite subset, suppose capital F, finite subset which is a capital F, which is given by suppose 1/3, 2/3, is the epsilon net of, for X. See this, suppose this is suppose a real line, or we consider whatever may be, suppose this is a real line. If we consider this set X 0 to 1, now we can write this as a 1/3, this is a 2/3, this is a 1/2. अगर आप यहाँ पे x लेते हैं, suppose this is a x, then you know that distance of x comma y, suppose x belongs to here, x belongs to capital X, then distance of small x comma 1/3, which is always less than 1/2, so epsilon is equals to 1/2. अगर आप यहाँ पे पॉइंट लेते हैं, समझो यहाँ पे पॉइंट लेते हैं, सपोज दिस इज x1, let also suppose x1 belongs to capital X, then there exists a distance of x1 comma 2/3, which is less than again 1/2, therefore epsilon is equals to 1/2. So we can say that therefore, what is that? Here we can say that the F is epsilon net. So F is called the epsilon net for capital X. समझ में आया क्या स्टूडेंट्स? ये हो गया एग्जांपल, वन एग्जांपल हो गया. We shall discuss another third example. Third example, a metric space. Okay. Let capital X is equals to 0, 1 with the usual metric. So we consider, suppose capital F is equals to the set of epsilon, 2 epsilon, 3 epsilon, n minus 1 epsilon. Suppose for epsilon greater than 0, n belongs to capital N. See here. Here F is what? F is epsilon net epsilon net for capital X. See this here, capital X is 0, 1 and see this, what f is equals to epsilon 2 epsilon 3 epsilon dot 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 n minus 1 into epsilon. Suppose this is a finite set, so we have to show that f is a epsilon net. This is 0, this is suppose 1, this set is denoted by f. Then we take the part epsilon, 2 epsilon, 3 epsilon, 4 epsilon dot 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 n minus 1 into epsilon. We shall consider this as a n epsilon. This is the finite set. Then if we take any point x, अगर आप यहाँ पे कौन सा भी point x लेते हैं, यहाँ पे ले लो x, suppose this is a x, then we have for small x belongs to capital X, which is equals to 0 to 1, then distance of x comma k into epsilon, 2k, 3k, 4k काही घ्या, k into epsilon which is less than epsilon. There exists a point x which is less than k epsilon, as like 2 epsilon, 3 epsilon, 4 epsilon, किंवा इथं आपण 2 epsilon घेऊ शकतो. That is distance of x comma 3 epsilon which is less than epsilon. So here f satisfies the condition for the epsilon net. So f is a epsilon net. Okay. So now we shall discuss the next definition, totally bounded. We shall define the totally bounded, the concept regarding the totally bounded set. What is the totally bounded here? Write down definition. Totally bounded. A set capital X of a metric space XD, a set capital X of metric space X comma D is called totally bounded. Is called totally bounded if X possesses an epsilon net for every epsilon greater than 0. X possesses epsilon net, then we can say that X is called as a totally bounded. Or we can write another definition, totally bounded, definition of the totally bounded set. Or a metric space X comma D is called totally bounded if for each epsilon greater than 0 there exists an epsilon net for x. There exists an epsilon net for x is called as a totally bounded. देखो ये इसी तरह से हम ए totally bounded की definition define कर सकते हैं. See this, for example, Example same, we shall take the example same. What is that example here? We shall discuss the same example. Now, suppose let capital X is equals to 0, 1 with the usual metric and capital F is equals to epsilon to epsilon dot 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 n minus 1 into epsilon. See this, for epsilon greater than 0, n belongs to capital N. Then the set X is called totally bounded. Totally bounded. See here. यहाँ पे suppose I have given that same example. This is a 0, this is a 1, epsilon, 2 epsilon, dot 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 in this way, n minus 1 epsilon. Suppose there is a point X, then distance of X comma k epsilon, which is less than epsilon. Therefore, F is such that, for any small x belongs to 0, 1, there exists any point, suppose k, which is less than n minus 1, such that distance of x comma k into epsilon, which is less than epsilon. Therefore, F is an epsilon net. यहाँ पे F क्या होता है? Epsilon net for x. Hence, x is called totally bounded. X is called totally bounded. See this. Suppose, note, this is a bounded set. This is a totally bounded. See here, totally we shall say that this is a totally bounded. 1 minute. This is a totally bounded. And this is a bounded. Totally bounded. Note that totally bounded implies bounded set. But converse does not prove. Second, but if bounded set does not implies totally bounded, अगर बाउंडेड सेट है तो उसे टोटली बाउंडेड हम नहीं कह सकते हैं, लेकिन अगर टोटली बाउंडेड सेट है, that is definitely we can say that bounded set. Okay, now we shall define this totally bounded. Third, a non-empty set A of a metric space x comma d is said to be totally bounded if for any epsilon greater than 0 there exists epsilon net फॉर कैपिटल ए। ये सभी नोट आप अच्छी तरह से याद रखिए, आपको समझ में आएगा। ओके, तो यहां पे हमें कुछ नोट और थ्योरम्स लेना है, खाली थ्योरम्स, स्टेटमेंट ऑफ द थ्योरम्स। ओके, we shall take statements of the theorem and one problems tomorrow, because there is another one lecture here, you have to follow it. Okay, now write down examples again. For note for every subset of totally bounded set is again a totally bounded. That means this implies that therefore suppose x is equals to 0 comma 1, x is equals to 0 comma 1, f is equals to set of epsilon 2 epsilon 3 epsilon dot 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 n minus 1 epsilon, and suppose we consider a set A, capital A equals to open interval 1 by 2 or 0 comma 1 by 2. Then also we can say that then A is totally bounded. A is also totally bounded. यहां पे ये भी क्या होता है, टोटली बाउंडेड होता है। इस तरह से हम ले सकते हैं, सपोज दिस इज एक्स, सपोज दिस इज एक्स 0 to 1, we can take another set, suppose A 0 to 1 by 2, so we can take epsilon 2 epsilon 3 epsilon dot 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 n minus 1 epsilon. If we take any point x which satisfies, here x belongs to 0 comma 1 by 2 such that distance of x comma such that which satisfies distance of x comma k epsilon which is less than epsilon. Therefore A is totally bounded set. This shows that every subset of a totally bounded set is bounded. आपको ये भी पता होना चाहिए सीधे। Next we shall discuss the Bolzano-Weierstrass property. Again we shall define the Bolzano-Weierstrass property. Definition. Bolzano-Weierstrass property. One definition want to express here. a metric space x comma d is said to be Bolzano to have Bolzano Weierstrass property. It is denoted by BWP if every infinite set of metric space x comma d has a limit point. Suppose this is a metric space xd, then every infinite set or every sequence has a limit point. Okay, suppose this is a sequence Sn or the set n has a limit point. Okay, हे यहाँ पे ये जो कल आया था बोल्जानो-वेierstrass प्रॉपर्टी की एक रिमार्क कल आई थी, इसके आधार पे हमने यहाँ पे डिफाइन किया है। चलो इसके आधार पे जो थ्योरम के स्टेटमेंट है, इप्सिलॉन नेट के आधार पे जो भी थ्योरम के स्टेटमेंट है वो हम कल देखेंगे। तो यहाँ पे हम स्टॉप करते हैं। नमस्कार, गुड बाय।